it's important to now understand how to handle any errors that might occur. In SYCL, errors are handled by throwing exceptions, and it's crucial that these errors are handled, as otherwise your application may fail silently. In SYCL, there are two main kinds of errors: synchronous errors, which are thrown directly to the user thread, and asynchronous errors, which are thrown by the SYCL runtime. Here is a diagram to help illustrate this. Any error which occurs within the SYCL interface will generate a synchronous error. However, any error which occurs after a command group has been submitted will generate an asynchronous error within the SYCL runtime. This is because once a command group is submitted, any error which occurs may happen in another thread. Here we have the vector add example from the last lecture. In this version, we don't have any error handling, which means if an error does occur, the application will fail silently. Except perhaps a log to the console, but that's implementation defined. The first thing to do to handle errors is to wrap any SYCL application code in a try-catch block. This will catch any synchronous exceptions being thrown by the SYCL API. Next, you must provide what is referred to as an async handler. An async handler is a callable, so a function object or lambda expression which can receive asynchronous exceptions. This happens when you either call one of the queue's member functions throw asynchronous or wait and throw. The reason for having an async handler is that when an exception is thrown by the SYCL runtime, this is often in another thread, which means there's no way to communicate this to the user thread. So having a callable which can handle asynchronous exceptions invoked when the user calls one of the above functions, these exceptions can then be processed and potentially rethrown into the user thread. An async handler must take as a parameter an exception list. The exception list is a wrapper around a list of exception pointers, which can be iterated over. Exception pointers can then be rethrown by calling std rethrow exception. Once an exception, synchronous or asynchronous, is caught, it can then be used to provide information about the error. The whatMember function, just like for any exception, will provide a message with more details about the error that occurred, though the exact details of that message is implementation defined. If the exception has an OpenCL error code associated with it, this can also be retrieved by calling the getCLCode member function. If there is no OpenCL error code, then this will return CL success. Most exceptions will also have a context associated with them. The hasContext member function will tell you whether there is a context associated with the error. Then, if this returns true, you can call the getContext member function to retrieve that context. Finally, we're going to take a look at how to debug SYCL kernel functions. As mentioned before, every SYCL implementation must provide a host device. This means that SYCL kernel functions can be debugged using a standard C++ debugger, such as GDB, LLDB, or Visual Studio. To do this, you simply use the host selector when creating your queue, and kernel functions will run on the host device. It's as simple as that. So this concludes the lecture on SYCL topology and creating queues. There should now be some time for us to answer any questions that you have on this.